Good afternoon. This is Dan Finnick from the Institute for Catastrophic Loss Reduction. We'll give folks a few seconds to sign in and then we'll get started. Okay, great. So welcome everyone to the ICLR Friday Forum for April 12th, 2024. This is one of our monthly webinar events that we host. Each month we present recently completed research related to ICLR's mission to make Canada more disaster resilient. We're very, very happy to have Simon Eng here today. He's going to talk about really interesting work that he's been involved in with the Hail program at Western. I'm your host. I'm ICLR's Director of Research, Dan Finnick. You may be used to seeing Dr. Keith Porter here. He's traveling this week, so I'm taking over for him just for the week. A note about some recent webinars that we hosted on February 23rd. We had Drs. Fung and Zhang talking to us about policy lessons from earthquakes in Japan and other earthquake-prone lessons. You'll be able to find a recording of that webinar via our webpage. If you have trouble finding that, please feel free to reach out, and we'll link you up with that. Next month on May 10, we're going to be talking about earthquakes again. We have Professor Sherry Malner, who will be on the line telling us about regional scale seismic hazard mapping in Metro Vancouver in British Columbia. Today, we're going to be talking about hail. So hail season starts in Alberta around the end of May or the beginning of June. Our Western University colleague, Simon Eng, will brief us on field investigations that the Northern Hail Project performs after hailstorms around Calgary, including, among other things, observations of building damage that they can relate to the meteorological info that they also collect. So Simon Eng is the Northern Hail Project's research meteorologist. He is unusually qualified to speak today, having been both a private consultant and a public sector research scientist. So he understands both the science side and its practical implications. And we're very happy to have Simon here today. Before we pass over to Simon Eng, a couple of notes about our agenda. So the webinar is about 90 minutes long today. Simon will speak for about half the time, and then we'll have a moderated discussion following the presentation. Please use the Q&A function to post your questions. Post questions throughout the webinar, and we will pose your questions to Simon after the presentation. Note that if we have a lot of questions, or if you have offered a lot of questions, so please offer as many questions as you like. But if we have a lot of questions, we may ask your first question and then move on to others before coming back to subsequent questions. The webinar is recorded. We will post Simon Eng's slides and a link to the video early next week. So if you have colleagues that are interested, please note that we'll have a recording available soon, and you can share it. And as with previous webinars, the link will be available via our website, the workshop site page within our website. So Simon Eng, thanks again for taking the time to present today, and I'll pass it over to you.
My pleasure. Thank you very much, Dan. So I'm just going to take a moment here to get the presentation up and running, and then I'll begin. So the process I'm sure we're all very familiar with now, watching someone set up the presentation view. All right, terrific. So first of all, thank you very much to everyone who is called in today or was taking the time to watch this recording afterwards. I understand everyone has quite busy lives, and again, really appreciate you taking the time to take in this information and for showing up as well. So today I'm going to be talking to the impact investigations of damage to hail events in Canada. This is part of our much larger Northern Hail Project research effort. To begin, I would also like to thank my supervisors and co-authors here, Dr. Julian Brimlow, who is the Executive Director of the Northern Hail Project, as well as Professor Gregory Kopp, who is the Research Chair for all things severe weather at Western University. So because this is going to be approximately a 40-minute talk, give or take, hopefully I don't run too much over that, and we have ample amount of time for questions. I will provide a brief overview here before we jump into the talk. so that folks have a good sense of what's coming over the next 40 minutes or so. So because I assume that there are at least a few folks who are new to this on the call, I'm going to do a very quick recap of the Northern Hail Project and where this research fits into the overall research effort. I'm going to then continue by starting by going into the importance of on-site damage documentation from damaging events. I'm going to describe some of what we're framing as forensic investigation methods that we're applying to these on-site investigations. I'm going to then get into some detail about some of the results that we've been getting from in-field research on performance of roofing materials specifically. I'm then going to talk about hail within the context of multi-hazard risk amplification. So often hail is accompanied by other elements that increase its damage or impact potential. And then I'm going to give a few success stories. We have already encountered a couple of cases where there have been resilient materials that have successfully mitigated impacts from some of these events. Then I'll summarize our preliminary findings and talk about some of the work that we hope to do this summer in the 2024 hail season. So to begin, just to give an idea of where this work fits into the overall goals of the Northern Hail Project, stepping back, we have the overall goal of the project, which is to benefit Canadians, municipalities, businesses, and other stakeholders, and to increase resilience and knowledge regarding hail and potential and hail risk and hail damage. To do that, and to be able to get into more detailed things like engineering interventions, like looking at things like risk assessments and risk modeling, you need good, detailed, high-quality baseline data to do that. So we have this pyramid here that is showing that at the base is 4 main areas where we are collecting that highly detailed information and data that will be the basis for those analyses that eventually lead to adaptation and resilience responses. Among those 4, one of them is what I'm going to be speaking to today, which is conducting urban and rural hail damage surveys. I'd like to acknowledge our partners as well. So obviously Western Engineering, Housing, as well as Western Libraries. So that's GIS, data gathering, collection, etc. Our main funders, the Institute for Catastrophic Loss Reduction, also hosting today's session. Also want to give a shout out to our other partners, in particular the IBHS. So that's they're essentially the ICLR's counterpart in the United States. But they've been established in the hail damage and impact space for much longer than we have, and they have all sorts of great laboratory equipment and other experience associated with that. So I'm going to be talking about a number of pieces of work involved with the damage survey work that we're directly collaborating with the IBHS on. And of course, our partners Instant Weather and Weather Logics, who are currently developing cutting-edge weather communication and products for the public. And they're also helping us with a number of elements, including, for example, helping us gather hail reports from their users and so on. So that's kind of a quick overview. And what we'll dive into now is the main subject here, which is, of course, looking at hail impacts in real world conditions. Now, I'm going to step back for a second and kind of frame why looking at hail impacts, why there might be some challenges in better characterizing how hail generates damage. So some of you around the table are going to be familiar with impact standards for building materials and specifically roofing materials, or may also be familiar with weather instrumentation that is calibrated or designed to measure or detect hail. In all those cases, either the impact standards themselves when you're testing building materials or the instrument calibration usually use something called the energy matching method, where we use either steel or wooden balls to match the kinetic energy of a real world hail impact to then test these materials or to test these instrumentation. The challenge here, and why we're very interested in actually using the information from real events, is because large damaging hail, in contrast to these standard methods, it's made of different material, it's made of ice. Why that's important is because at the impact energies that we're talking about, those ice projectiles actually deform. They behave very differently than either wood or steel, and when they interact with these impact receivers. And they're also not spherical. So I have a variety, this is from a separate component of our research project, the field operations portion. And you'll note the variety in sizes of these much larger hailstones. We have hailstones here that are on the order of about 50 to 80 millimeters maximum diameter. And what I'd also like to point out is the hailstone on the far left that kind of looks like a bit of a snowball type of shape, and the hailstone on the right, which is kind of an oval, flat disc type of shape. Both of those came from the same storm. So individual thunderstorms, when they produce large hail, there are a variety of sizes. And as you can see, they're absolutely not spherical. And as a matter of fact, the larger you get, the larger the hail becomes, the less regular those shapes become. And I also want to point out the structure of the hailstone in the middle, where there are all these spikes and protrusions on it. So again, those are going to interact very differently with those impact receivers than what our standard calibration or testing methods usually do. And as we can imagine, because the thing that is causing the damage in these events is ice, the evidence itself disappears rather quickly. So what we're working on and what we're trying to apply here is finding other methods to reconstruct what has happened in these events to better understand how those interactions occur. Now, we're very deliberately using the term forensics here. Sorry, go ahead.
Apologies, Simon. Sorry to interrupt, but we're getting a bit of an echo. Maybe while you're presenting, if you wouldn't mind muting your speakers, that might do the job.
See if I can find some.
Okay, so apologies to everyone for the interruption there. All right, so to continue. All right, beginning with so now we're going to get into the actual methodology of the process here. So to begin, when we talk about high impact events, if the fundamental idea behind conducting forensic investigations is this: if you have had multiple events where you have had significant impacts from the same or similar hazards, what that generally means is that you have existing vulnerabilities to those hazards. If you do not then go in after those events and record the impacts and learn from them, you remain vulnerable to those same hazards. So the idea behind conducting forensic surveys and forensic investigations is to investigate what happened so that we can learn from it. This is often executed for other hazards, most notably for things like extreme wind. So we know about damage surveys that are conducted following hurricanes and tornadoes, things of that nature, as well as for earthquake engineering. We know that this has also been something that's been going on for several decades. But for hail, and specifically from an engineering and meteorological standpoint, these types of surveys are quite rare. So beyond the work that we're doing for Canada under the Northern Hail Project, which we began only about 2 years ago, and we hope to continue as long as possible on conducting these. We know that there have been occasionally individual pieces of research. A very good study that came out of Romania that was published earlier this year. And we also know that there was some work done in the United States, and quote Marshall et al., number of studies done in the 1990s and early 2000s, again, more from a meteorological lens and getting a better sense of if remote sensing was working properly or algorithms for that. And interestingly, and this came through over, of all things, Twitter a few months ago, there was also some research done in the 1960s in Italy, again, to confirm or to get a better sense of the severity and the types of storms that were occurring in that area and generating, in that case, very significant agricultural impacts. But again, very, very rare and only done in kind of small pockets internationally over the past several decades. For our work, again, we've only been running for about 2 years, and we managed to document 13 cases so far in conducting these detailed assessments. Only a handful of test cases in 2022, but in 2023, we managed to basically turn this into a national program and in earnest conduct the majority of those cases investigations last year. So this map here, we can see that we've covered 4 provinces, and we've conducted, and each of these dots represents a survey, a GIS located survey point. So you can imagine that each of these represents essentially a damaging hail swath that was assessed. A number of them in Alberta, one case in Saskatchewan, several surprisingly in Manitoba, and we were particularly surprised to be conducting damage assessments in Southern Ontario last summer. Some of the storms which we'll go over here. Now, when I use the term forensics, I'm using that term very, very explicitly. We're quite literally borrowing from crime scene investigation techniques, and I'll explain what information we get from those in a moment. But beginning with looking at those different parallels, we have things like soil impression analysis. This is a patch of ground in Alberta that and what it looks like after a large hailstorm had passed over. And I've circled a few of these, but you can see several other what are essentially ground indentations that were left by large hailstones. You also have parallel to tool mark analysis. So one of the items that we like to look for during a damage assessment are air conditioning units, and specifically the rear end and the cooling fans on the or foils on the air conditioning units very easily take damage and can leave impressions or can give you these very strong impressions that show, in this case, hailstones. But we also know that there's other debris, other stuff flying around in some of these storms, and so we want to differentiate between which impact marks are left by hailstones versus impact marks which might be the result of other flying debris. So that's where there's the importance in generating those distinctions. We also have more generally scene documentation and forensic data collection. I should mention that as part of all of this, we have just started to put ourselves in contact with other forensic experts. And in particular, we're going to be collaborating on the scene documentation and language component even of objectively recording the information at these damage sites. That in and of itself is a whole area of forensic investigation, forensic science. On the right, we also have high velocity spatter. So I'll give a few examples of this later on in the talk as well, where if you have either a painted surface on wood or a metal surface that has some oxidation on it, following a hailstorm, you'll see a series of these spatter marks where some of that kind of, at least the very top layer of that surface has been removed. And this can give us, again, an idea of the number of hailstones, how large they were, if they're falling at an angle, and so on. And finally, on the bottom right, I've referenced ballistics. So as some of you may know, we also have this kind of interesting overlap where very, very large hailstones have similar kinetic energies to small caliber firearms. So you're not going to have the exact same type of damage, but again, we can investigate work that's been done in that field to get a better sense of what we can do and what types of information we can discern from the evidence that's left over from hailstorms generating essentially ballistic damage. And one thing I do want to point out here is, if you recall, within one of the earlier pictures where the hailstones some of them didn't necessarily have smooth surfaces, but had some of these protrusions. I suspect that in some cases, when we're seeing penetration damage like this is a house siding that has had both the siding and then the vapor barrier penetrated or broken through. It's very possible that those protrusions or those spikes that you have on hailstones may be contributing to impact characteristics and damage characteristics that you just simply wouldn't get with the model smooth sphere that we've been using for testing. I'll also be speaking to this kind of multi-hazard perspective. One of the things we've noted, especially looking back at the historical record, but also seeing it as we continue, when other severe weather events occur in conjunction with hail events, especially if you're talking about strong tornadoes, at least in the public consciousness and media, we will see that all other damage, all other impacts for severe weather events tend to be overshadowed by the one or two very, very spectacular and understandably very spectacular events. So here I have a map of some of the impacts in southern Alberta that occurred on July 1st of last year, so Canada Day of last year. And many of you are likely familiar with the fact that we had an EF4, or a very high-end tornado located near the town of Didsbury, about 40 kilometers north, or sorry, 45 minutes drive north of Calgary. But that day we had a number of other storms, including a number of hail events with diameters upwards of 3 inches or 75 millimeters. And those are indicated here by those blue dots. Now, this area here in particular, I want to focus on. This is another case that we're going to be looking at a number of examples from. Is in the town of Killam, so approximately a 2.5-hour drive northeast, again, of the tornado. This was likely the second most intense storm of the day, where we had a wind-driven hail event that damaged well over 200 square kilometers of crops and also generated some pretty spectacular building damage in terms of roofs, windows, and siding to several towns along Highway 13 here. And so all this to say that when you have that essentially these hazard events don't occur in isolation, and that they can also combine to generate impacts that are greater than they may generate individually. So in terms of the meteorological parameters, so beginning with this, as Dan mentioned, what we're trying to do with this work is gather information so that we can try to get a better matchup between what meteorological parameters and characteristics occurred, and then understanding what the resulting damage or impacts can be to different impact receivers. That's really what we're trying to do here. So from the meteorological standpoint, in terms of better characterizing what the hailstorm did and what it looked like, we can derive things like maximum hail size. In the middle of the middle center image here that you can see on the slide is an example of a hail sample that residents saved in their freezer following an event. That's fantastic information for us because we can collect that hailstone, measure its dimensions, weigh it, and also get information from the resident. For example, how long after the storm did they collect the stone, so we can get a rough estimate of how much of it may have melted, things of that nature. But here we have actual physical evidence from the event that we can measure and weigh, and then we can start to get a better sense of what type of kinetic impact energy was involved with this event. When we don't have those physical samples, we have these forensic indicators. So I showed some of those impact marks. Soft soil is fantastic for taking impact marks from or generating impact craters from hail that we can then directly measure to get a sense of maximum size. And there's also event imagery. Most of the time, folks take lots and lots of pictures during and after the hail event. And then using reference objects, we can get a better sense of what those hailstone sizes were. Just as important for hail impacts are the hailfall density and the distribution of those hail sizes. So I mentioned earlier, we have these scuff marks. So this is a zoomed out version of the image you saw earlier. So here we can get a better sense of, especially for large hailstones, what the actual fall density was, how many hailstones were falling per unit area, and also a rough idea of the size distribution. And also following events, folks will also take pictures of the ground. And then from that, you can get a sense of, again, how many hailstones fell, what was their fall density, and did they accumulate to any depth, or were they fairly scattered in terms of spacing? And then finally, we can also get wind speed estimates. So we're using the enhanced Fujita scale, which is most often applied to get wind speed estimates for severe thunderstorm wind events. And in a lot of these hail cases that were accompanied by high winds, the high winds themselves were also significant enough to start generating damage. That gives us a sense of how fast the winds were that were accompanying the hailstones, and then we can better understand what that means in terms of how much additional energy that may have given the hailstones, and that'll be critically important for our understanding. So the next couple of slides, now we're going to be looking at different types of roofing material and some performance measurements or performance characterization that we've been able to locate here. We'll start with our standard candidate here, asphalt roofing. So, of course, the most common type of roofing product that's used across North America. And as we also know, the least well-performing, especially for roofing materials that are not rated that don't have any kind of impact rating or testing associated with them. Here we have a really interesting case that we found in southern Manitoba from one of the events, where we had a house that had two different ages of roof on the house. So to save some money, the homeowner replaced a portion of their roof approximately 6 years ago, and I assume to help in the hopes of saving a bit of money and not replacing the entire roof of the structure. So what this did was essentially two things. One is we still had some much older 16-year-old roofing material that was exposed to the hail, and we have a close-up here that shows you all the pock marks and kind of granular removal that occurred with that on that portion, the older portion of the roof. But also we have a kind of this interesting case where you can get a kind of a contrast in the performance between different on the same building for the same type of roofing, but one portion of which is about 10 years older than the other. We've also encountered composite roof products. So in this case, we have what's I believe a glass fiber type of material that's been built to kind of look like corrugated metal. But if you look closely here on the picture on the right, you can see that it is indeed a composite material. And in the zoomed out picture on the left, you can also see there's a metal roof next to it. And again, harkening back to some of the forensic methods that I was talking about, you can actually see some of the brighter points on the roof here where the spatter marks from the hail kind of left their impression. But looking at this composite material, and this is likely characteristic of all materials that have some polymer component, some sort of plastic component, that they will be subject to aging and becoming more brittle with time. So we've seen cases where you have brand new materials like this, and they still have some significant ductility to them, and will essentially bounce back and not take very much damage at all. But it only takes a few years or even a year of aging under the sun to then undergo enough of a transformation so that the materials do become brittle. And in this particular case, there wasn't very much of a wind-driven component. So you can see some of the worst damage is on the very ridge of the roof where it's essentially punched a number of holes. And in this case, we had a number of hailstones that were on the order of 50 to 60 millimeters across, possibly larger at this particular location. And you see the owner has made some attempts at fixing the roof with various products here. But again, unfortunate that potentially promising roof product was taking so much damage just after a bit of aging. And finally, looking at just an example of metal roofing systems. So this is from the Killam, Alberta case that I mentioned earlier. It's a drive shed at a farm that was located pretty much right in the middle of the damaging hail swath. And this particular drive shed began to have roof leak after the event. Now, I know for the most part, metal cladding and metal roofing, we're looking at more aesthetic damage, but usually the performance remains the same after a hail event. But if you have large enough hail, and if it hits the exact wrong points on your material, in particular seams, it can still generate damage and again result in leaks when you've hit those critical areas. So harking back again to the forensic damage indicators that I showed earlier, I basically boosted the contrast on a zoomed in portion of this roof. So those red circles indicate areas where we can confirm that there are hail impact marks. And I've located one that is right on the seam here on this portion of the roof. So, and we have other portions of the roof of this particular roof that look very similar. So part of this is, again, getting a better sense of how do we confirm what the mechanisms are for specific building material and material system type failures. So I'm going to again get back into the multi-hazard component here and talk in a little bit more detail about the effects of wind-driven hail and the effects of wind specifically on increasing the impact energy from hailstones. So we have a pretty straightforward concept here, a diagram on the far left, where we have the red vector here that's representing the terminal velocity, so that the terminal velocity or the fall speed generated obviously by gravity. And we have a green vector here that is meant to represent a bit of a lateral motion or additional component generated by the wind. What that results in is an angled fall vector, so your total vector or resultant vector for the hail fall is down to the right. And what that means is that the total velocity of that hailstone is higher than even its terminal velocity. And so a bit of trigonometry here, where basically that is the result of the terminal or resulting velocity is the resultant vector is the result of the square of the terminal velocity added to the square of the wind component, and then square rooted. So just as an example, for the threshold of what we consider severe hail here in Canada, a 2 centimeter hailstone, if it is being pushed laterally by a 70 km/h wind, that doubles the impact energy. That very roughly increases it. Effectively, it's equivalent to increasing the diameter of the, or what the type of speed increase that you would get in the terminal velocity if you increase the diameter of the hailstone by about 5 millimeters. So instead of having a 20, if you have a surface that is hit perpendicular directly on by that resultant vector, you're looking at an impact energy that is equivalent to a 1-inch hailstone or 25-millimeter hailstone versus a 2-centimeter hailstone, which doesn't sound like much, but when you get to much larger hail size categories, that's enough to knock it up to the next hail size category. If we're talking about things like roofing materials standards, impact resistance standards, that extra 5 millimeters of added velocity or equivalent diameter in terms of the added velocity can be enough to knock you up by another category. Why is this important for things like roofing? Well, what we are finding in both our initial results on the damage surveys, as well as another branch of research that we're working on, which is looking at historical events, is that wind-driven hail storms, at least a lot of the most intense hail damage events that we're seeing, do appear to have a wind-driven component to it. We know that the 2020 Calgary hailstorm that resulted in our first billion-dollar hail event was a wind-driven event. We had winds of on the order of 70 km/h, in addition to hailstones that were maximizing out at about 60 to 70 millimeters in diameter. And we've also seen this in a number of other major historical hail events in Canada. We have a really great case from 1953 in Kemptville, Ontario, just south of Ottawa, that again had reported hailstones on the order of 4.25 to 4.5 inches in diameter. So that's 12 plus centimeters in maximum diameter, that were also accompanied by high winds. So we have stories from that event of people in things like brick institutional buildings that still had to run to the back of the room because windows were blown out and hail and wind and branches were getting into the structure through that means. We also know that there have been several billion-dollar events recently in the United States that have been documented that, again, were a combination of this large hail and high winds. So the most dramatic example of what that kind of lateral addition can do in terms of change the direction and the effect specifically on sloped surfaces and sloped targets. I have an example here from Germany of tile roofs, which tend to have a binary failure property to them. They tend to stand up very well to hailstones up to a certain kinetic energy, but then past that, then you have a brittle failure. And this is a case where the sloped roofs that were facing that wind vector were very severely impacted. And then if you went to the other side of the building, the other side of the roof had little to no damage. Another potential target or impact receiver that tends to have a sloped surface are, well, the green energy component here of the solar panels. So we have Scottsbluff, an example here from Scottsbluff, Nebraska last year. And this is just an example that I was able to locate. We do know that there have been solar farms in Canada that have been severely impacted as well. And again, one of the assumptions, and I've read this in a number of places, is having a sloped surface is supposed to help you with hail impacts in terms of resilience, because if it's falling straight down, that means that only a portion of the hailstone's energy is going into that surface. Not so if there's a wind component. And if there's a wind component, then there is an added kinetic energy to it and not a reduction. So to very simply illustrate this is what I'm talking about. If you're adding those two vectors up and your resultant vector is at the slant, if you have a sloped surface like a roof or like a solar panel, that surface, if it's directly normal to that impact vector, is going to take a much harder hit than it would otherwise for a hailstone of the same size. What this also means is that our impact standards that are based on assumptions associated with just using the kinetic energy from the terminal velocity. What that means is that when you have this wind-driven component, smaller hailstones will have the same kinetic energy, and surfaces like sloped roof surfaces that should be theoretically taking less damage because they're not oriented towards the fall vector may actually be seeing similar kinetic energy or greater kinetic energy from smaller hailstones than what they're theoretically rated for. So this is why these little details, these little additional components are really important especially looking at hail within the larger context of occurring with additional events. Another example, and we've one of our damage surveys here is again looking at a case where it had this storm generated everything except for a tornado. This is a case in Lindsay, Ontario from August 3rd, where we had a combination of very large hailstones, stuff getting approximately up to about 63 to 67 millimeters in diameter. That's the size of a tennis ball, in addition to flash flooding, in addition to extreme winds. So we had wind damage indicating wind gusts of up to 115 kilometers per hour in this area that were also accompanied by very large hailstones and very heavy rain. And the combination of your hail and wind also generated significant amounts of debris, or sometimes even if you have enough hail, the hail itself can form drifts over your drainage infrastructure, and then you will get flash flooding in areas where you may not be seeing what the design rainfall or what the drainage should be able to withhold or be able to take care of. When that drainage is blocked, you then have a rapid accumulation of water, in addition to all the other problems that you can see here. And so in this particular case, the rain was so heavy that we had both flash flooding in these drainage areas, in these poor drainage areas, as well as impacts on roofs. So the meteorological, and also putting all of this into context, the importance of having meteorological findings and getting a much better sense or reconstruction of what's happened at the ground, we can then get a better sense of what risks that event actually posed. And this is a very good example from earlier, from late last summer on August 12th. On the bottom right, I'm going to draw your attention to this shaded yellow area that has that indicates where we had evidence of hailstones that were either 50 millimeters in diameter or larger, so 2 inches or larger in diameter. That's what's considered significant severe hail, and which starts to generate very severe damage to most impact receivers, especially vehicles, and you also again start to see pretty severe damage to roofs and so on. And embedded within that, we had hailstones, especially on the kind of western and southern edge of this area, that were exceeding baseball size, or on the order of 70 to 75 millimeters or larger. The largest one we found was approximately 86 millimeters in maximum diameter. Here we have a picture of it, and that one weighed approximately 102 grams. When you get to approximately baseball size, so 70 to 75 millimeters, that's when you're getting into kinetic energies that are a significant injury risk for people. So just as a point of comparison, your bike helmet is designed for about 120, 130 joules of impact energy. That's roughly what gets generated by baseball size hail. So again, a good comparison to get a sense of what types of forces we're talking about. Why is that important for this particular case? Well, on the other side of Lake Simcoe, located here under this X, there was an outdoor music festival with 40,000 people in attendance. So they were actually under a tornado warning for a short period of time from the same cluster of storms. Thankfully, those storms did not appear to produce tornadoes, but one of those storms did, as it tracked across the lake, become a significant hail event. So this I would consider a near miss, because not only was there at least the possibility for tornadic potential there, but one of these storms ended up essentially going ballistic and generating very, very large hailstones. And neither of those things mix very well with a large outdoor event where people don't have a lot of time to respond. And watching news coverage of this event afterwards, the folks at this festival were also completely oblivious as to what the hazards that were around them at the time. So again, just to reiterate that the part of the importance of characterizing it, of getting a very good sense and reconstruction of these events based on this forensic information, is that you can then get a better sense of what risks we're actually dealing with some of these cases. So now I'm going to give two examples of resilient materials. Now, unfortunately, because of our delay here, I'm going to try to go through these last couple of slides fairly quickly so that we have time for questions. But going back to this Killam, Alberta case, to explain what we're seeing on the screen here, these are visible satellite images of the farming area surrounding the town of Killam about a week after the storm. And I've highlighted in this yellow oval here that the area where we have some very significant crop damage. So you'll note here, I'm just going to go over it with my cursor. Yeah, we have lots of green fields to the north, and then as you go further south, you have these huge kind of yellowed areas. all of that represents very, very significant hail damage to those crops and this whole area. And on the far right, I have a zoomed in section here. The farm that we're going to be looking at for this case is covered by this red X here. So it's just located to the immediate southeast of the town of Killam. But on this image on the right here on the zoomed in portion, I want to point out, you see these green islands here, and then there's streaks just to the bottom right of these green islands. Well, those green islands are basically clusters of trees. And what you're seeing is the sheltering effects that those clusters of trees had on the surrounding crops. So you actually have these streaks that occurred because the crops just immediately downwind from those tree sheltering areas were survived. So this again gives you an idea that this farm that we're going to be looking at under this red X is in an area of very significant hail damage. So it was a very intense hail event to begin with, and they were located in one of the most intensely damaged parts. So again, this idea of having a forensic assessment, you take all these different pieces of evidence to show to then come to essentially an event reconstruction. So another good example of this here. So this is the home I'm going to be focusing on in terms of resilient roofing material. And when here we're facing the garage portion of the home. So that's where this white truck here in the other pictures, that's the same white truck located here. And you'll notice on the bottom half of the garage doors are covered in scuff marks. So I'm going to zoom in there. So again, another piece of evidence to confirm that very dense hailfall and a number of very large hailstones embedded within that hail event. But here we have a drone shot on the image of that same roof on the right. And this roofing material is again a resilient aluminum-based roofing material that was purchased and installed specifically for hail resistance. And the homeowner indicated there was absolutely no impact to it that they could detect. They'd already had the insurance adjuster over to have a look at it. And we talked a bit about also the wind-driven hail component. The angle of impact was roughly from the northwest here. So the roof itself, the lower portion is on the left, and there's a higher portion on the right. So this was a roof that was also angled towards the direction of impact for the hail. And again, even with the added component of an added kinetic energy of the wind, again, this roofing material did its job. Second and last example of resilient material is an example of siding that also withheld a significant event. So again, this is a storm, the first one that we actually did a detailed assessment on that occurred in Pinoca, Alberta on July 16th of 2022. It was also a multi-hazard event. They had flash flooding in the downtown area. As you can see here, a picture of immediately following the storm showing that there was complete ground cover. And we also know that there were very large hailstones in this event as well. And specifically, there were a number of windows that were lost in addition to your standard roofing damage and siding damage. So again, very, very intense storm. But one homeowner that we got into contact with, because we had heard that they had lost several windows in the event. So again, during the storm, the hail and wind were significant enough that the windows were blown out. So you had a breach of the building envelope and they lost windows. But because they had invested in significant in good siding, unlike their neighbors, they had no damage to their siding, to the point where they said, you know what, we can follow up later by phone, but don't bother visiting us. We don't have a lot of damage to show you. So even doing this for a short period of time, we are also finding some strong evidence indicating that when people invest in having resilient cladding or roofing materials on their homes and on their businesses, that stuff actually works. And very plain as day when you compare it to the damage to different non-resilient cladding materials that further on adjacent structures. So to do a quick summary of the preliminary findings, talking about building material performance, again, not a surprise given what we already know, but it's always good to get ground truthing and collect the information of ground truth. These findings is that asphalt shingles, vinyl siding, and older windows, so windows in, say, older brick buildings, your kind of soda lime single pane type stuff, those markedly have poor performance. Numerous other existing materials, and if you can think of any other type of house siding that includes hardy board, wood shakes, etc., regularly outperform these types of cladding and roofing materials. Another interesting finding, especially for the cases in Ontario, are that the maximum hail size, at least in terms of initial media and social media reports, is often underreported. That case in Lindsay, for example, we had generally reports of golf ball or slightly larger than golf ball hail, so that's in the 45 to 50 millimeter range. And we immediately found we immediately found reports and a physical sample we were able to measure of 63 plus millimeters in diameter. So again, that's critical because when we were trying to understand what types of hail are required to cause the severe damage that we're worried about and that we need to design against, develop material and testing protocols around, we need to know what those kinetic energies are so that we have numbers to be able to develop design values around. So that's why understanding things like maximum hail size are still really critical, and why it's important to do this extra type of work for digging for that information. And as I mentioned before, it appears that some of the most intense crop and building damage that we're finding, again, comes from a combination of not only having large hail, but large volumes of hail. So you have numerous hits, as well as some wind component to give it that extra bit of kinetic energy to carry it over that threshold where, again, hailstones that might be moderately damaging, you can then, again, increase it by essentially a size category by adding some additional wind and lateral to that. And I didn't talk about crops or for vehicles at all during this discussion, but just as one example from the findings that we've had in agricultural areas, I'm going to draw your attention to the right here. And these are just a couple of what remain of some canola crops. And this is a stem that is no wider than a pencil or a pen. And just to give you an idea of how dense the hailfall is in some of these events, I've counted at least 11 individual strikes on this stem from that of hail impacts that were large enough again to generate damage. So reconstruction of events, and also through that reconstruction, again, getting a better understanding of what those actual damage mechanisms are. So finally, I'm going to talk about our damage survey work for 2024 and what we hope to expand upon, and a few sub-projects that we're hoping to work on here. So first and foremost, as I mentioned, no one else is currently really doing this other than, of course, the one group in Romania in Europe. Although there was quite a bit of interest in this type of work when we went to the hail workshop in Germany. So I'm hoping that other research groups are also going to pick this methodology up as part of their toolbox. But what we are hoping to do is basically write the book on this, develop an international hail damage survey protocol with a number of our international colleagues and collaborators. A portion of that is going to be improving our roof damage survey guidance techniques. So specifically the folks at the IBHS have lots of great lab tools to be able to evaluate and analyze and objectively assess imagery of damage from these events. And so we want to be able to be collecting information in the field that is of high enough quality for those types of systems to then evaluate and get a much better objective analysis of the damage. We are also working on the development of a hail intensity scale. We know that there are a few that have been developed in the past, and we are testing those out essentially and trying to come up with further kind of enhancements and improvements on that through the work here, through the damage assessments, but also through our other streams of research. And then in terms of sub-projects, so specific research goals for the damage survey work for this year, we are very interested in this other concept of non-severe high volume hail roof impacts. There was a talk given by Brenna at the IBHS a few months ago on this particular topic, but we talk generally on one sense of larger hail and higher impact energies causing worse damage. But there's also a component of hail that is becoming much more clear as well, where even small hailstones that are generally smaller than what we would consider severe. So I talked about that 2 centimeter threshold. Those events, especially if you have a high volume of them and you have repeat events over the same locations, appear to also have a degrading effect on roofing materials. And so what we want to do this summer is those types of events tend to hit Calgary pretty often. So we're going to have a number of opportunities to potentially have a look at roof damage from those cases to see if there's what we can learn from those cases. We also have a couple of other projects, again, working closely with the IBHS, looking at material harvesting. So if folks are replacing the siding and the roofing material on their house after a hail event, we're hoping that at least in 1 or 2 of those cases, possibly more, that we can then go and harvest that material, send it down to the lab, and then have it physically tested to get, again, a much better sense of what that in situ actual strength of those materials were. And finally, homeowner follow-up. What that means is when we are out doing these surveys, if we have a particularly severely damaged property, we're also going to ask homeowners if they're okay with us following up with them either a few months later or a year later to see if there are any other problems that showed up, and also how their experience has been in terms of trying to recover from the event. So I'm going to end on the acknowledgement slide here. As you can imagine, all of these pieces of work take many, many hours, very, very long days of hard work. And I cannot stress enough how grateful I am to the rest of our research team, to our interns, as well as to staff and interns on the tornado project side who have provided just countless hours in supporting these. And again, these, as you can imagine, some of these days are also quite tedious. But again, like I like to tell some of our other staff and our interns, the reason why we're out doing this research is because we all have the same condition in terms of being absolutely passionate about the weather. And so again, I'm very grateful to all the folks here on the slide for their time, their effort, their passion in supporting this work. So with that, I'm going to stop and take any questions.
Great, thank you, Simon. That's amazing work. That's really, really interesting.
Thank you.
So far. So please do post your questions in the Q&A box. We've got a couple here, but to give you a chance to think about your questions, I've got a few questions here. So you've got several examples of damage. So actually, one general question is, I think there's often the perception that roofs are most vulnerable and most commonly damaged during hail events, but you point at lots of examples where other components of buildings are damaged, including siding and windows. Could you, I know it's still early days, but could you give a general assessment how frequently roofs are damaged, different components of roofs? Like I'm also thinking like roof vents. Is there impact? And
for sure. So and I may start by quoting some of ICLR's numbers back to them. So we know, for example, and that's why I was kind of bringing in the specifically also focusing on still on kind of roofing impacts, even from the wind-driven component, is it's pretty obvious that your roof is going to be essentially the first thing that takes a hit from a hailstorm, right? It is the biggest target in terms of surface area, and that's presented to the hailstorm. And so I was thinking about this week, trying to kind of reconcile that, because those other components, as you said, do get damaged especially when you have that wind-driven component. My understanding from what we have so far is that the majority of your damage will still be from roof impacts. I mean, we saw that even with all of these wind-driven hail events. So obviously the Calgary hailstorm is a great example, where we had major siding damage and blown out windows and vehicle damage with that. But out of the $1.3 billion loss from that event, $800 million was still from roofs. And so even in storms where you have that wind-driven component, what that means is that, as I showed with the kind of the slope surface diagram there, is roofing is still going to be a big part of that damage, because especially anything that is facing that wind is just going to get hit even harder. So even if you don't have very significant damage on some parts of the roof because it was somewhat protected by that wind component, the part that was facing the wind is going to get very, very severely impacted. So again, it's pretty clear from this work that roofs will remain kind of the main impact receiver on buildings. But I will say that there is a lot of variance that people are also seeing in damage that can't just be explained by roof damage. And so we think that secret ingredient is the wind-driven component. So when you're seeing a smaller proportion of the damage, it's still going to be a majority, but whenever you see a smaller proportion of the damage in a specific event that's associated with the roof damage, and a larger proportion from some of these other damage impact receivers or building surfaces, that's likely the wind-driven component that can explain that. So there's the other thing that we're well aware of is that there's a lot of fantastic research already being conducted, and has already been conducted on this main problem being the roof damage. But that variance and the impacts to those other elements like siding, like windows, like HVAC systems, that's a very large gap in our understanding. So we still have to take a much closer look at those impact receivers and those building material types to kind of cross that gap to be able to really kind of close in on really mitigating the damage from these events.
Right. Yeah. Great. Thanks. And a follow-up question, I suppose, is you have several examples of scuff marks on siding.
Yep.
Do you have any info? Was that fibers? It looked like pretty durable siding, fiber cement. It wasn't like a penetration of the siding at all. Are scuff marks, are they permanent? Like, is that something that would potentially trigger an insurance claim for?
Yeah. So that's a very good question. So I think in some cases, when you're looking at very, very stiff materials, so I'm thinking in particular hardy board. So for the folks around the table who might not know what that is, that's basically a composite concrete type of product that is essentially cement with some type of fiber, whether that's wood fiber or some other type of reinforcing fiber to give it some tensile strength. That stuff tends to not take any kind of, unless it's not properly supported, or of course, the case of having very, very large hailstones that can damage that type of siding. But in the cases where you have that, where you have very hard siding or very, very stiff materials, we haven't seen, we've seen where it appears that there isn't any actual physical damage to the siding. The worst case that you might have there is you might need to put a new layer of paint on there. But that said, there could be some damage there that isn't immediately visible. So one of the other, I didn't include this in our list of items for this upcoming storm season, but we're also considering or thinking of using 3D scanners to look at some of these building surfaces so that you can have a much more, pardon the pun, but in-depth analysis or assessment of that surface. Because as we well know that there can be damage, but it might take very close look or other means to actually detect that damage. So in those particular cases, it does appear that it's mainly a very good performing siding material, and that it's mainly aesthetic impacts. But that's where information like these follow-up interviews with some of the residents, you and I have talked about maybe getting information or chatting with some insurance adjusters who are out in the field and actually going house by house, looking at these things to get a better sense of what those kind of longer term impacts might be, which may reveal some damage that again wasn't necessarily immediately obvious.
Great. Thanks, Simon. So we have several questions here from attendees.
Terrific.
So we've got a question here from Piran. What are your top tips for individuals to prepare for potential hail?
Okay, good stuff. So what I would say is one, and this is again part of the reason why we started the Northern Hail Project, is to be able to have a more objective sense of where within Canada hail preparation is especially needed. But we do know that we do already know certain areas that are particularly hail prone. And why this is important to answer this question is this is also a level of risk question, right? How much do I need to worry about hail impacts? So if you're in a hail prone area, so that portion of Alberta where we're conducting the study, we get large portions of the southern Canadian prairies as well. And we're also trying to get a handle on parts of southern Ontario and southern Quebec and how hail prone they actually are. And if that risk is changing. One is to have, if you can, have some of that resilient siding. The least resilient siding, as we've indicated, is vinyl siding. So other products that either have more resilience to them, whether that's the hardy board or even wood slats and various other types of wood siding. if you can afford them, or if you have the opportunity to replace the siding, say your siding is old and you're looking for a replacement, get those more resilient materials. And the same for the roofing materials. There are impact rated roofing materials that are available. The IBHS is a fantastic resource for determining and locating which particular products are most are best performing. And again, so you can even have asphalt type products, but some of those products are again rated for higher impacts. So that's more of a statement on resilient materials. One of the other things that we've noticed is that if there's any kind of protection around a structure, usually in the form of vegetation, that tends to take some of the kinetic energy from the hail from those hail strikes. So we've noticed that there's, again, similar to what I showed on that satellite image for crop damage, there's some shadowing effect that happens when you are downwind from stands of trees or other structures that offers some protection. Now, we know that there is kind of a balance here, because if you're in a wildfire prone area, the advice is to not have vegetation too close to your structure. So there's a balance component there, and that's also why, again, having better risk or hazard occurrence information is really critical for this. But I will point out that there is that if you can have some sort of structural sheltering component, that also helps reduce the hail impacts. And we've also seen that when comparing events in the Canadian prairies, flat open terrain, versus the events we've seen in Ontario, where some of these have been in Canadian Shield territory, where again you have very dense forest cover, which again appears to help quite a bit in terms of reducing the impact damage to building surfaces. And finally, for vehicles, what I would say for damage mitigation is just to keep an eye on the weather. If you have a severe thunderstorm threat in your area, they'll usually mention that if large hail is going to be a component of that threat in both the watch, so that's several hours before the storms form, they can indicate what some of the main threats are going to be that day. And then in the thunderstorm warning, when there is an event that is imminent or happening, they will usually also indicate a rough idea of hailstone size. And you need something on the order of 3.5 to 4 centimeters to start causing damage to vehicles. So if you're anywhere in terms of that risk, try and find some. If you have a garage, get the car in the garage. If not, I have some friends out in the Canadian prairies. They'll do things like put mattresses on the windows of the vehicle, things like that. Just anything that you can do to protect the surface of that vehicle. Initially, and doing that early on in the day, if you know that there's a bit of a threat, right? Taking 5 minutes to put your car in the garage, or to put some padding on the windows and that kind of thing, you'll be glad you did that if you end up getting under one of these hail cores. So those are kind of the main pieces of advice that come to mind at the moment. But that's something that we should probably develop into an actual checklist for folks here.
Right. Yeah, good point. And so good points about the relationship to other hazards as well. So fiber cement is a good thing to use in wildfire-prone areas, but maybe untreated wood siding is less ideal. But a lot of these areas not prone to wildfire, so that would give you greater flexibility. So I think you may have answered this question already, but if you wanted to share anything else on shelter belts, Mark.
Yep, for sure.
Hi, Simon. Great talk. I was wondering about the effect of shelter belts on hail damage. For example, if the shelter belt is located upstream of a home, how will it reduce damage on the home from a wind-driven hail event?
Yeah, so I mean, I could I can just basically indicate that we've seen some pretty good evidence that they do reduce things like shelter belts in farmland do reduce impacts. Now, to a point, the shelter belt will reduce impacts over an area that is, closer to the size of a building. When you're talking about the agricultural fields themselves, the majority of the fields still will get pretty severely damaged. As you saw again from that image, there are, the portions that are directly adjacent to the shelter belt will tend to be significantly less damaged. But that's not a majority of the field, unfortunately. But yes, so it's a very long way of saying that absolutely we have a good amount of evidence so far that shelter belts do offer offer at least a partial protection from wind-driven hail.
Right, great, thanks. And so we have another question here about a specific roofing material. So they're asking, how does ceramic roofing fare in Calgary? And you talked about several roofing material options, non-rated asphalt roofing, and even like older versus newer asphalt roofing. And the example you mentioned with damage was aluminum roofing. A general sense of materials that seem to perform better, or is it really all down to that impact rating? Because if that was a non-impact rated aluminum roof, maybe it would have been damaged. But general sense, any materials that seem to perform better?
Yeah, and actually the tile roofing one is a good question because we haven't encountered that yet in any of our damage surveys. Now, again, unfortunately we've only been able to get out and do about 13. We hope to double that number this year. So I can't comment directly on the concrete tiles through our experience. What I can say from having conversations with our colleagues and from looking at events in other geographical locations. So I gave that example in Germany, for example, is the ceramic tiles and anything that has kind of that ceramic component to it. They do seem to have a kind of a binary failure mode in that they're hard and tend to hold up to a certain point and with very little damage. But then when you cross that threshold where it's just enough to crack the tiles, then you run into serious problems and end up with large holes in the roof immediately after that. I know that there are large portions of Calgary. In fact, some family friends, I remember being fairly young, this was in the late 90s, and visiting. It was a brand new subdivision in Southeast Calgary, and it was all concrete or ceramic tile roofing. And even as a small kid, I remember looking at that going, I don't think that's a good building material for this area. But to your point, that again depends on if they're impact rated or not. And so there are things that you can do to ceramic materials, like adding fibers for tensile strength, that will very quickly increase their impact rating, or their impact, their ability to take impacts. So that's obviously an option if you're really keen on having that as a roof type. I understand it's very pretty, but it's that added step of just ensuring that you have something that if you're going to be going that route, have something that has been tested and that is impact rated. Again, maybe good for the residents, but we haven't yet encountered that, but we expect to in the near future, in the next year or two, to have a survey where that roofing type will be part of the assessment.
Yeah, great, thanks. There's two questions here, and I think they're somewhat related. And so earlier in your presentation, you had the sort of triangle of the foundational research and working your way up to sort of the ultimate outcomes of the program. So one question is, there's one question here that is really about specific practical advice. So great to see the effectiveness of some hail resilient materials, and this is from Sohail. What information collected on effectiveness and availability of such materials is being shared with the public? Are you, I suppose, what you're describing here is foundational research collecting the evidence. Is there a plan to also translate this into public communications, policy type advice?
Absolutely. So I will give the standard caveat that as you mentioned, this is the very early days of that initial core data collection component. So we've only conducted 13 of these kind of forensic assessments. We're hoping to be able to draw conclusions that you can then use as evidence for providing policy advice, providing evidence for changes or additions to building codes, that type of thing. We would want a much bigger sample size, but that is absolutely the goal, is to collect that much larger sample size. And then from that larger sample size, then having enough data to be able to draw those types of conclusions to then develop that practical application. Where the Northern Hill Project is very much, I don't know if cradle to grave is the right description of it, but it's that full life cycle, or that full cycle of risk reduction, from learning enough to help with improving individual hail event forecasts, all the way through to developing that evidence base that we need to determine what those changes and recommendations need to be, and then for actually implementing those in terms of getting them into getting them into building codes and getting them into policy recommendations. So that's a very long way of saying that is absolutely a target of ours, but we are also aware that we don't have enough data yet because it's early days to draw those types of conclusions.
Sure. And I think a related question, and I know I asked Julian about this at a previous section that you did for ICLR, but currently we don't really have like an official hail climatology for Canada, like a hail hazard map, like we have for other hazards. It's not, there's no hail information, included in the sort of climate indices table of the National Building. Could you sort of describe maybe how this work would eventually lead to something that could be used for national public policy guidance?
Absolutely. Yep. So I'll tie in the damage surveys in a second, but the overall work by the NHP is targeted at exactly that, which is getting a better sense of what both our historical climatology has been of damaging hail, and also understanding through getting a better sense of what conditions produce these particularly severe hailstorms and these different hazard combinations, because that's clearly becoming important, or it clearly is important for explaining some of the more severe events. Through better understanding the mechanics and the physics of hailstorms, we can then better understand what changes in climate might mean in terms of what changes we might see in hail risk. So it's putting all of those individual pieces together to do exactly that, which is to get that hail climatology sorted. And so these damage surveys are part of getting that very, very high resolution data that's needed to properly characterize these hail events. Because as you're aware, what we're used to having in climate in our climate data sets are essentially point data or individual data points. Whereas for a true representation of hazard occurrence, what you actually need are not individual data points, but the total, let's say, damage footprint from each of the individual events. We need to know what the intensity gradation is within those. I could say that we had a hailstorm that produced 12 centimeter or greater hailstones, but was that over just a small area, or did it do that through its entire life cycle? Those are two very different risk characterizations for even an individual event. So where these damage surveys are really coming in is getting a sense, what does that distribution of hail size look like within an individual storm? How big is the damage footprint, or the area that was impacted by the very damaging stuff, the 5 centimeter or larger diameter hailstones, versus maybe the larger footprint from the storm that might have had generated very minor vegetation damage kind of around that. So these and also as I mentioned in the talk, getting a much better sense of what those maximum hailstone sizes are and what that hailfall density was. So all of that information is a significant improvement on the individual event characterization. And then when we have a whole bunch of events that have been evaluated to that level, we then understand what that statistical distribution might look like in terms of, how big or small do hail footprints tend to be, and what do the extremes look like in those in those kind of similar size categories. So that's where the damage survey work in particular is really helping, is to get a much clearer picture of what individual events look like, and then doing many of these damage assessments so that we have that granularity of data on many events, and then be able to do those kind of higher level statistical analyses that can then feed things like a proper climatology that we can then use for design standards and for response decisions.
Great, thanks, Simon. So we're getting close to. I've got 2 more questions. If there's any more questions, please post them. And if there's something that occurs to you later on, I'm sure you can connect with Simon. But I mean, so far this is incredibly interesting and lots of new information on that we're getting from you here. So one question is,
I think we lost Dan for a second here.
on hail events during storms, and that could be useful information. I see several insurers on the line. It would be helpful to know how the public, how the insurance industry might support your work. And I know we've talked about restoration contractors potentially setting up a way to offer data to you. But is that information helpful? And how might we ICLR help you engage with the industry a bit more?
Oh, absolutely. So I should point out your audio cut out for about 30 seconds there, so I missed the first half of that question. But I will answer the second half about how can members of the public, industry, etc., help with this information. Members of the public, we are very active on social media, specifically Twitter. I refuse to call it the other thing. And we also have a Facebook page. And as I mentioned, also we have a couple of weather product service providers, Instant Weather and Weather Logics. Through all of those mediums, you can provide, you can tag us and provide your own hail reports. So if you see large hail, and again, we're usually looking for stuff that is 2 centimeters or larger in diameter, let us know. We are finding through some of our radar-based research that there could be as many as 400 plus severe hailstorms. So storms that are producing areas of hail that are hailstones that are 2 centimeters or larger and therefore potentially damaging. We could be having as many as 400 of those events per year across Canada. So any ground truth information that we can get in terms of imagery, and what I'm particularly interested in for this work is if you're seeing any severe damage that might be caused by hail, if you can, obviously, if it's safe, record, tag, and kind of provide us with that information and connect us with that information. In terms of industry, what we very often find, and as you mentioned, I was a consultant for a number of years prior to this in the risk assessment, climate change risk assessment space. People who are on the ground 24/7, doing this work as a day-to-day thing, see a lot of stuff that we don't necessarily have a good handle on, having just started on this. So folks like insurance adjusters would be able to help confirm some of the information that we've had. So we're having some of these ground truthing research on what materials are resilient and what aren't. But that type of information, insurance adjusters have in their back pocket because they've seen it so much. So that goes back to a previous conversation that we had, trying to maybe open some lines of communication there to get a better sense of, do some of our preliminary findings ring true? Are there other types of impacts that you've seen that are things that really we should be looking into as well? Other building materials that maybe we haven't encountered that are important, that kind of thing. So those would kind of be my two answers, and especially on the public side. And we could, I think, and that we probably should have added this to the presentation, is what our Twitter contacts are. But if you look up Northern Hail Project on Twitter, we have a reports account, and that's specifically for hail and hail damage reporting. And then we have another kind of main account that kind of gives regular updates on work that we're doing. So when we're at workshops or conferences or doing collaborations with some of our collaborators, some of the other international scientists that we're working with, there's updates on our work there as well. So I would encourage folks to follow us there. And also, if you see impacts, we may not know about it. So please let us report it to us. And then the last pitch that I'll give for that is, if you are in a position where you're taking pictures of hailstones, please, if you can, have a reference object next to it so that we can then, kind of in a more scientific sense, actually scale that hailstone, and that will actually make it that makes it more scientifically usable. We have a lot of pictures of people holding hailstones in their hands. There's so much size variance in people's hands. We have no idea how to scale that, right? And I'll throw this in for my boss as well. If you can have insulated gloves or something like that while you're handling stuff. So you saw while we were handling hailstone samples there in some of our pictures, we're all holding gloves, and that's because hail melts so quickly, especially in warm summer temperatures, that again, that can actually significantly affect kind of the characteristics of the hail. So that's my pitch for collecting information from folks if they're interested, and also, of course, if it's safe to do so.
Okay, great. One last quick question is, how are you getting your findings from your assessments out do you have a publication series? Are you publishing journal articles?
Yes. So right now we're working on the best. We're working on finding ways to do that most effectively. So what we're beginning with is basically doing short write-ups on each individual event that kind of give an overview of our findings and basically what area that we covered and so on. So those will become publicly available very soon. I can't give you a release date at the moment, but within the next few months. The individual reports for each of these cases will be available. Beyond that, we're going to be also summarizing some of the research that some of this work. As you know, it's very important to when you're conducting new kind of cutting edge research in specific fields, that the peer review process from other scientists is critical. So we're also going to be obviously writing this stuff up into journal articles and having go through the peer review process, which is again critical for basically validating those findings and so on. So now that's less accessible, but as part of those journal article releases, obviously there's also press releases and explanatory kind of more plain language explanation components to that as well that will go to the public. So those are kind of the first two immediate portions. But again, also when we're conducting this work, we're giving folks updates over social media. So any very fascinating findings or impacts that we're seeing, those we try to get out as soon as possible for that as well. So there's a number of different means that we're using to get this information out to the public and to get these findings out. But again, with that kind of scientific rigor that we want to make sure we're applying to all this research, as I said, with the peer review process and so on.
Great. Thank you, Simon. Thanks for an amazing talk. It's really great that it's being done in Canada. And of course, there's all sorts of implications for the public good and better building practices and reducing the impacts of extreme events and all the impacts that go along with that on homeowners and on solid waste and all of that stuff, aside from it just economic damage. So really appreciate the work and appreciate the program. And thanks again. We look forward to following along with your work over the coming years.
Awesome. Thanks so much for having me.
Great. So that concludes the webinar today. And just a reminder to folks on the line that the next webinar will be on May 10th. And we'll have Professor Sherry Molnar in from Western University, who will talk to us about regional scale seismic hazard mapping in Metro Vancouver. And with that, I will say have a good day.